Hello, so we are group B-13 and our project was diagnosis of autism using fMRI scans. So I am here with our video with like explaining my project. So our topic as you can see it was loading. Firstly we will upload the fMRI scans into the pipeline. So we will be uploading .nii file and it can accept .nii and NIFTI file, and it will automatically proceed to detect autism related neural signatures. So the as we go into a pipeline, firstly as I upload, as you can see we are being shown MRI thumbnails. So these thumbnails have been derived from the MRI CON app. As I will I can show it here. We have this MRI CON app in which I am directly extracting these images from there. So as you can see, these are the snippets which you can see in and we have extracted it through the API. Now as you can see, the it initializes the processing. Firstly the state log, the time it's the log is getting updated on its own. The starting was initialization. Firstly initialization took place, then pre-processing and motion correctness were the first steps, as it reduces the random noise, and it was a combination of spatial realignment and temporal filtering. Apart from that, in signature feature plots, this graph is constantly changing. This graph basically signifies the time points that we get while judging our model. So the x-axis represents time points and the y-axis represents the signal intensity, that is blood oxygen level dependencies, to have ROI correlations. As you can see, our firstly we had spatial normalization, and after that it was computing ROI correlations and graph features by reducing Gaussian noise. And for reducing Gaussian noise, like we are using here high pass filter. Then apart from that, after that we after CNN we are deriving the scores, and these scores are being updated after each step. So we have some of the important features here which will help us to detect whether there is autism or not. Now as you can see further, we had these three images, and after normalization the pipeline extracted the meaningful brain features and the multigradient plots that you can see here. The heat map, firstly heat map was used to identify the core features and for additional binary prediction. And CNN logs, these are the logs of the CNN pipeline. Then I will show you, these are the some of the smoothing millimeter that we used here. Now coming on to a final report, the final report says that the person is autism positive with a probability of 57.5%. As you can see, that's the multicolor plot that shows there are many different colors, but the core colors here are yellow, blue and green. So the green stands for moderate activation, while blue and dark blue are for low activation or hypoactive regions which are concise to a single voxel, while the yellow stands for high activation. And these are some of the quantitative MRI metrics. So currently our model predicts that it's autism positive, this brain fMRI scan. Now I will close it and show you how our pipeline works. So for in our notebook, firstly I switched to GPU. Then after that, as you can see, my first step was to load the files, then flatten them for the CNN, because CNN generally takes only one day input. Then I performed CNN plus autoencoder approach, but it didn't work well. So I moved forward and optimized it further. And these were some of the data sets which appeared. Now coming on to then show you, I loaded all this ABID dataset and then filled it with the data. Then I will show you directly. I had to classify the ABID data into two types, phenotypic and non-phenotypic. Then after that, the only CNN was giving a test accuracy of 71.71% kind of. Then our plan was not to go with only CNN but to optimize it with CNN plus graph transformer approach, which earlier gave me an accuracy of 73%. Then I switched to autoencoder, but later we realized that with CNN plus autoencoder it was only giving an accuracy of 57.9%. That's 58% only. So we had to go with CNN plus graph transformer approach only in our model, as you can see. And this is our final project that we have done. Here the autism positive, as you can see here, the output is, and in our final report too we have autism positive as the output. Thank you.